Hi everyone, in this video I will be showing you how to find least common multiple or the LCM. First, let us define what is this LCM. It's the least number that a multiple of two or more numbers. It is also the smallest number divisible by both numbers. Now, the LCM can be used to find a common denominator of two or more dissimilar fractions. By the way, video tutorial on operation on dissimilar fractions are available also in this channel. Now, hint to find the LCM. The LCM will always be equal to or greater than the largest of the two or more numbers. Let's have some examples. Find the LCM. Okay, so as you noticed, the three examples, all the numbers are prime. What is a prime number? Prime numbers are natural numbers greater than 1 that only have two factors, 1 and the number itself. If all the numbers are prime, all you need is multiply them to get the least common multiple. Therefore, 5 times 7 is 35. So that's the LCM of 5 and 7. For number 2, 3 times 11, 33 is the LCM. Number 3, 13 times 23 is 299. That's the LCM of 13 and 23. Now, what if the given numbers are not all prime numbers? Okay, there are three methods in determining the LCM of a set of those kind of numbers. Number 1, listing the multiples. Number 2, division method, also known as the ladder method. Number 3, prime factorization. Let's apply all these three in the following examples. Example number 1, find the LCM of 4 and 5. Let's use method number 1, listing the multiples. The LCM is the first common multiple for the given numbers. Let's get the multiples of 4. There are 4, 8, 16, 20. Then for 5, we have 5, 10, 15, and 20. Now, stop listing the multiples if you have reached their first common multiple. So that means the smallest common multiple of both numbers. Therefore, obviously, their common multiple is 20. So that's the LCM. Okay. Now let us apply the second method, division method or ladder method. There are 4 steps in applying this method. Let's start with step 1. Find the smallest prime number that is a factor of at least one of the numbers 4 and 5. So what's the smallest prime number that is a factor of at least one of them? So that is 2. Write this prime number on the left of the given numbers 4 and 5. Separated as per the ladder arrangement. Step 2. If any of the given numbers 4, 5 is a multiple of 2, divide it by 2. Okay, so therefore 4 divided by 2 is 2. Write the quotient below it. Then bring down, so 5 is not divisible by 2, obviously, so we're going to bring that down. Okay, and then step 3, let us just continue the steps until there is no possible further division. So 5 or 2, so the smallest prime number that is a factor of 2 is 2. So that's 2 divided by 2. Write the quotient below it. 5 divided by 2 also again is not divisible by 2. So you're gonna bring that down. So we can't continue anymore because there's no more any smallest prime number that is divisible by or from 1 and 5. So 2 on the left side of the ladder are the divisors or the greatest common factors, and the last row 1 and 5, these are the remainders. So let's go to step 4. The divisors and the remainders are multiplied to obtain the LCM. Now there's 1 as a remainder, so you need not to use that one, because any number multiplied by 1 is the resulting is the number itself. Okay, so therefore the LCM is 2 times 2 times 5, that is equal to 20. Okay, let's try method number 3. Prime factorization. It involves finding the prime factors of the given numbers and identifying the least common multiple. Take note, prime factors. Let's start with 4. Prime factors of 4 are 2 times 2. For 5, there is only 1, that is 5, because 1 is not a prime number, it's a factor of the prime. Therefore, the LCM is 2 times 2 times 5, that is equal to 20. Let's try another example. Number 2. Find the LCM of 18 and 27. Now let's use method number 1 again. Listing the multiples. For 18, we have 18, 36, 54. For 27, there are 27, 54. So we have stopped listing because we have found the first common multiple of the given numbers 18 and 27. Therefore, 54 is the LCM for both numbers. Okay, method 2, division method. Again, let's follow the 4 steps. Find the smallest prime number that is a factor of at least in one of the numbers, 18 and 27. So what's the smallest? Okay. Smallest is 2. So write this prime number 2 on the left of the given numbers 18 and 27, separated as per the ladder arrangement. Then for step 2, if any of the given numbers 18 and 27 is a multiple of 2, divide it by 2. So we have 18 divided by 2 is 9. So you're going to write the quotient below, 18. Then 27 is not divisible by 2, so you need to bring that down. Then again, think of a smallest prime number that is a factor of at least one of the numbers, 9 and 27. So I think there is, which is 3. So 9 divided by 3 is 3. Write the quotient below 9. 27 is also divisible by 3, that is 9. Write it below 27. Then continue the steps until there is no possible further division. 3 and 9 have a factor that is smallest prime number, and that is 3. So let's continue dividing. 3 divided by 3, the quotient is 1, right below it. And then proceed to 9 divided by 3 is 3. Alright, is there any other or smallest prime factor that is a factor of at least 1 or 3? Yes, there is factor of 3. 1 is not divisible by 3, so you need to write it or bring that down. Of course, 3 divided by 3 is equal to 1. So that ends the division. So the numbers on the left, again, these are the divisors or the GCF. And the numbers at the last row are the remainders. So we need those in getting the LCM. That's the step 4. Multiply divisors and the remainder. The remainders are ones, so you don't need to write them or multiply them with the divisors. Okay, so we have 2 times 3 times 3 times 3 is equal to 54. Okay, method number 3, prime factorization. It involves again the prime factors of the numbers, then multiply them to obtain the least common multiple. For 18, its prime factors are 2 times 3 times 3, and for 27 there are 3 times 3 times 3. Okay, let's box the common factor or common prime factors of 18 and 27. So there are 3. So therefore the LCM is through 2 times 3 times 3 times 3. So how did we get those? So as I've said, so just copy 2 because it's not too common. Just copy it down. And then of course the other 3. And then we have 2 pairs of common prime factors. So write each pair once or copy each pair once. So therefore we have 2 times 3 times 3 times 3 is equal to 54. Okay, another example. Let's start with method number 1. Find the LCM for 4, 12, and 20. So for 4, The multiples are 4, 8, 12, 16, so until 60. For 12, there are 12, 24, 36, 48, 60. And then for 20, there are 20, 40, and 60. Okay, we found the first common multiple for all the given numbers, 4, 12, and 20, and that is obviously 60. So that's the smallest common multiple, and it is also known as the least common multiple. Okay, method 2. Step 1, find the smallest prime number that is a factor of at least one of the numbers 4, 12, and 20. Again, it's also 2. So write the factor on the left of the given numbers as per separated by the ladder arrangement. Then perform the operation. That's step 2. Okay, if it is a multiple, so divide it by 2. So 4 divided by 2 is 2. Proceed to 12. 12 divided by 2 is 6. Again, write the quotient below the given number. And then 20 divided by 2 is 10. So is there a smallest prime number that is a factor of any of the numbers 2, 6, and 10? So there is. Again, it's also 2. Then let us divide because the given numbers are divisible by 2. So 2 divided by 2 is 1, 6 divided by 2 is 3, 10 divided by 2 is 5. So can we still continue? Is there a smallest prime number that is divisible by 1, 3, 5, or any of these 3 numbers? Okay, there's none. So let's stop the division. So therefore, of course, the numbers on the left are the divisors, and then the remainders are the numbers on the last row. So for the step number 4, we're gonna multiply the divisors and the remainders to get the LCM, and that is 2 times 2 times 3 times 5. Again, do not include 1 anymore. And that is 60. Last method, prime factorization. Okay, for 4, we have 2 times 2. For 12, we have 2 times 3 times 2. And then 20, we have 2 times 2 times 5. So the LCM is, so there are 2 pairs or 2 sets of common multiple or common prime factors of the given numbers. So we're going to write each set once. Okay, there you go. And then copy 3 and 5 and perform the multiplication. Therefore, we got 60. Okay, so I hope this helps you in finding the LCM for any given numbers. So that's it. I hope you've learned something from this. Bye.